If one night the sky were no longer silent, if the familiar points of light suddenly became cold observers staring back at us, would you still call them neighbors? The galaxies closest to Earth appear gentle and distant, yet beneath their soft glow may lie storms of radiation, silent acts of cosmic consumption, and skies that have never known stability. They are close enough for their light to touch our eyes, but far enough that we have never truly understood them. In your view, is closeness in the universe a gift, or a warning written in starlight? Share your thoughts in the comments below. And now, let us step into the neighbors in the dark. What if the galaxies closest to us are not friendly neighbors at all? What if they are old kingdoms of light, beautiful at a distance, but ruled by physics that does not care whether anything lives or dies? We call them neighbors because their photons arrive in our eyes quickly by cosmic standards. We call them neighbors because we can point to them with a finger. We call them neighbors because naming something makes it feel less unknown. But distance in the universe has no morality. It has no tenderness. It has no promise. It only has time. And so the real question is not whether nearby galaxies are good or bad. Iwasologies in Natakana. The real question is whether we have mistaken familiarity for safety. Whether we have confused a soft glow in the night with a gentle world. Edwin Hubble once wrote, "Equipped with his 5 senses, man explores the universe around him and calls the adventure science." I was. That line matters here, because our senses are easily seduced. A galaxy looks like a calm spiral, a delicate smear of light, a quiet painting hung on the black wall of space. But a galaxy is not a painting. It is a living weather system of gravity and radiation. It is a memory palace built from collisions, mergers, and slow tidal theft. Carl Sagan reminded us, the cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. That's fine and servated. It is poetic, yes, but it is also brutally literal. The same stars that built our bones also explode. The same processes that forge carbon also bathe worlds in lethal radiation. So when we ask whether nearby galaxies are harsh, we are really asking a more intimate question. Are the places that create life also the places that casually erase it? To feel this, imagine standing on a beach at night. Across the water, you see lights from another shoreline. They look peaceful. They look like a town sleeping. But you cannot hear the storm behind those lights. You cannot smell the smoke from a fire in the hills. Distance makes danger look like decoration. In astronomy, that illusion is constant. Take Andromeda, our nearest great spiral companion. In photographs, it seems serene, like a silver wheel turning slowly in silence. But Andromeda is massive, and mass has consequences. It has consumed smaller galaxies. Not with a sudden bite, but with a long, patient pull. It leaves behind streams of stars, stretched like torn silk around its halo, the faint fingerprints of things that used to be separate. From far away, those star streams look like artistry. Up close, they are the fossil scars of gravitational capture. Now bring that down to a scale the mind can hold. If a small galaxy is like a canoe on a dark ocean, then a giant spiral like Andromeda is a tide you cannot argue with. You do not need malice. You only need gravity. And gravity does not hate you. Gravity does not love you. Gravity simply remembers where mass is. So the harshness of a nearby galaxy can begin with something quiet. It can begin with being too close to something larger. When a dwarf galaxy orbits a giant, it can be stripped of gas, the very raw material needed to form new stars and new worlds. This process has a gentle name, but a severe outcome. It is like living in a village, where every winter someone comes and quietly removes your stored grain. No screaming, no sudden violence, just slow starvation across millions of years. And yet, harshness can also be loud. Some galaxies are not merely places where stars are born. They are places where stars are born too fast. They are starburst galaxies, cosmic furnaces running hot, burning through their fuel in a frantic episode of creation. In such places, supernovae happen more often. High-energy radiation becomes part of the background weather. Shock waves ripple through clouds of gas like thunder through a valley. If a habitable planet exists there, it may live under a sky that is never truly calm. A useful example is the kind of galaxy astronomers call a starburst, like Messier 82, often nicknamed the cigar galaxy. It is close enough for us to study in detail, and it is in a state of intense star formation, likely triggered by gravitational interaction. This is one of the first lessons of nearby galaxies. When galaxies come near each other, they do not simply pass like polite ships in the night. They reach out with invisible hands. They disturb. They compress gas. They ignite waves of star birth. And where there is rapid star birth, there is also rapid star death. Here is a picture to hold in your mind. Imagine a calm forest that burns at a normal pace, one tree at a time, leaving room for life to adapt. Now imagine the same forest forced into a sudden frenzy of growth, thick with dry fuel, packed too tight. One spark changes everything. A starburst galaxy is that forest on the edge of a wildfire, except the wildfire is written in supernovae and cosmic rays. But perhaps the deepest harshness is not in the stars. Perhaps it is in the hearts of galaxies. Some galactic centers are quiet, like ours is most of the time, with a supermassive black hole that is present but not actively feeding. Other centers are awake. They are active galactic nuclei, where matter spirals inward, heats up, and launches jets of energy that can extend for thousands of light years. Those jets can sculpt the surrounding environment, heating gas, shutting down star formation in some regions, or triggering it in others. In a poetic sense, it is as if the galaxy has a lighthouse at its core, but the beam is not light for sailors. It is radiation that can sterilize. Consider Centaurus A, a nearby galaxy with a dramatic history that includes a merger and a very active center. It is a reminder that a galaxy can be both ancient and unstable, both beautiful and violent, depending on where you stand within it. If you lived far from its center, you might see a sky rich with stars and think you were blessed. If you lived too close to its core, you might be living under the cosmic equivalent of an industrial blast furnace. And then there is another kind of harshness that does not announce itself with brightness. It is the harshness of emptiness. Some galaxies, especially in dense environments like clusters, can be robbed of their gas by the hot intracluster medium, the thin but energetic plasma between galaxies. They can become quenched. No new stars. No new sun-like systems forming. Just an aging population of old stars, slowly reddening as time pulls the heat from their cores. To a human heart, that kind of galaxy feels like a monastery after everyone is left. The architecture remains, but the singing is gone. This is where we must be careful with the word near. It's one of finer did. Near to us does not always mean near to stability. Our local group contains the Milky Way, Andromeda, Triangulum, and many smaller galaxies, including the Large Magellanic Cloud and Small Magellanic Cloud. The Magellanic Clouds are close enough to be seen by the naked eye from the right latitudes, and they are in a complicated gravitational dance with the Milky Way. Their gas is being pulled. Their star formation is being influenced. They are like small companions walking beside a giant, sometimes sheltered, sometimes battered by invisible tides. If you want an example that makes this emotionally real, think of an ant walking on a sleeping dog. The dog is not trying to harm the ant, but when the dog shifts in its sleep, the ground moves. The world changes. A step becomes an earthquake. That is what it can mean to be a small galaxy near a large one. Now, step back again, because there is a more subtle twist. The universe is not uniformly violent. It is patchy. It has calm suburbs and dangerous downtowns. Even within one galaxy, the environment can vary wildly. Near the spiral arms, star formation is active, and massive short-lived stars are common, which means more supernovae and more intense radiation fields. Farther out in the galactic disk, things can be quieter. In the halo, it can be quieter still, though not free from cosmic rays and the slow rain of interstellar particles. So if someone asks, are nearby galaxies harsh? The scientist's honest answer begins with another question. Harsh where? Harsh when? Harsh for what kind of life? Because life, if it exists elsewhere, might not fear what we fear. Our biology is tuned to a narrow range of conditions. We are the children of a relatively steady star in a relatively calm region of a spiral galaxy. We are used to long stretches of stability, punctuated by manageable disasters. But a different kind of life might treat radiation as sunlight. It might live underground by default. It might exist in oceans beneath ice. It might find a starburst sky thrilling rather than terrifying. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you." Because design down ever say jing. There is a second meaning we can borrow from that. The universe is also under no obligation to make comfort for you. It does not design safe neighborhoods. It does not label dangerous streets. It simply evolves. It expands. It rearranges. And yet, there is a strange mercy hidden inside this indifference. Because the same processes that make a galaxy harsh also make it fertile. Supernovae sterilize, yes, but they also seed space with heavy elements. Collisions disrupt, yes, but they also trigger star formation and create new planetary systems. Even black holes, in their violent feeding phases, can stir gas and shape the future architecture of their galaxies. What looks like cruelty from the perspective of a fragile creature can look like creative destruction from the perspective of cosmic chemistry. Here is a final image to carry with you. Picture a garden tended by no gardener. Plants grow where the wind drops seeds. Storms prune branches with no plan. Fire clears old growth. New growth follows. From one angle, it is chaos. From another, it is renewal. A galaxy is that garden on a scale so large, our language becomes small. So when we call the nearby galaxies neighbors, we are saying something about ourselves, not about them. We are revealing our longing to belong in the cosmos. We are revealing our instinct to humanize the unknown, to give it a face, to assume a relationship where there is only distance and time. And perhaps that is not a mistake. Perhaps it is part of how the universe learns to look at itself through us. Stephen Hawking advised, "Remember to look up at the stars and not down at your feet. Try to make sense of what you see, and wonder about what makes the universe exist." Aid not free dough. That wonder is the bridge between fear and understanding. Because the moment we replace the word harsh with a more precise question, we begin to see more clearly. What environments do nearby galaxies actually contain? What hazards are common? What regions might be calm? What timelines matter? And that leads us, naturally and quietly, into the next step. If we are going to judge our neighbors, we must first enter their night without assumptions. We must stop treating their light as a greeting. We must treat it as a clue. Because the truth is not written in comfort. It is written in the ancient glow that reaches us across the dark. So now, let us begin where all these questions truly belong. Not with answers, not with certainty, but with a careful walk up to the edge of what looks familiar, and the admission that familiarity can be a disguise. Welcome to the first chapter, The Neighbors in the Dark. What if the safest place you can imagine is only safe because you have never seen it from the outside? What if the Milky Way looks peaceful for the same reason a calm ocean looks harmless to a sailor who has never met a storm? To measure what harsh really means in nearby galaxies, we have to begin at home. We have to stop romanticizing our spiral arms as a gentle cradle and instead treat them like a laboratory. Because harsh is not a mood. It is a set of conditions, radiation levels, explosion rates, gravitational chaos, and time. From where we stand, the Milky Way feels like a quiet neighborhood. The night sky above your roof does not hiss with danger. The stars do not look like weapons. They look like decoration. But that calm is partly an illusion created by distance, and partly an illusion created by survival. We are here precisely because this particular corner of the galaxy has not erased us yet. Carl Sagan once reminded us, "We are made of star stuff," says created. It is a beautiful sentence, but it carries a shadow, because star stuff is forged in violence. The elements in your bones, the calcium in your teeth, the iron in your blood, were cooked in stellar interiors and scattered by stellar deaths. If we are made of star stuff, then we are also made of star endings. And so the first honest step is this: the Milky Way is not peaceful. The Milky Way is selectively peaceful. It is peaceful where we are, often enough, for long enough, that biology can write its slow poem. But beneath that poem, the galaxy still keeps its older language. Gravity, radiation, collision, extinction. You can imagine it like living on the flank of a sleeping volcano. The grass is green. The soil is rich. The sunsets are gentle. And because the mountain has been quiet in living memory, you start calling it safe. Yet the calm is not a guarantee. It is a pause. In our case, the volcano is not a mountain, but a structure tens of thousands of light years wide. Its lava is not fire, but energetic particles. Its ash is not dust, but gamma rays. Its tremors are not earthquakes, but gravitational tides that can rearrange whole star systems. We orbit inside a disk, crowded with stars, and crowded with history. Every star you see is a story of pressure and time. Some stories end softly, many end loudly, and a few end so loudly that the galaxy remembers. Consider supernovae. A massive star lives fast, burns hot, and dies in a detonation that can outshine an entire galaxy for a brief time. If one happens close enough, it can bathe nearby worlds in radiation. It can damage atmospheres. It can stress DNA. It can rewrite the future without ever meaning to. For a listener trying to picture this, imagine a lighthouse whose beam is not light but sterilizing energy. Now imagine that beam sweeping across interstellar space. If your planet happens to be in the path, you do not get a warning. You only get consequences. And here is the unsettling part. Our galaxy has had many supernovae. It will have many more. The Milky Way is not a museum. It is a living engine. Engines produce heat. Engines produce exhaust. Engines produce failures. Then there are gamma ray bursts, rarer but more extreme. Think of them as a needle of energy, a cosmic spear thrown across the dark. If it strikes a planet from the right distance and orientation, it can strip ozone, flood the surface with ultraviolet, and tip ecosystems into collapse. Not because the universe hates life, because physics has no feelings. So when we say our galaxy is calm, we should say it the way we say a forest is calm. Calm between lightning strikes. Calm between droughts. Calm between the seasons that thin the trees and the seasons that regrow them. But the Milky Way is not only harsh in its explosive events, it is also harsh in the slow, constant ways. Cosmic rays pass through you right now. Most do nothing noticeable. Some leave tiny scars. Over geological time, those tiny scars add up like wind-carving stone. Even our own star, the Sun, is a reminder that home is not synonymous with safe. Solar flares and coronal mass ejections are eruptions of magnetism. They can disrupt technology, scorch satellites, and light the polar skies with aurora like ghostly curtains. And if you scale this up to more active stars, especially young ones, you begin to understand that many planets may live under skies that never truly rest. A helpful analogy is to imagine two homes. One is in a quiet suburb where storms come rarely. The other is on a coast where hurricanes return like a seasonal ritual. Both are homes. Only one allows you to forget the roof might be torn away. Now, follow that thread inward, toward the center of our galaxy, because if we are using our home as a measuring stick, we cannot ignore the heart of the house. At the center of the Milky Way sits a supermassive black hole, Sagittarius A star. It is not currently devouring everything nearby like a mythic monster, but it does not need to be dramatic to be defining. It is a mass so great that it shapes the orbits of stars tens of thousands of light years away. Stephen Hawking gave us a line that still echoes in modern physics. Black holes ain't as black as they are painted. I was watching in defense of this. He was pointing toward a deeper truth. Even the darkest objects have a kind of whisper. Even the most extreme places have rules. And rules, in the cosmos, can be more terrifying than monsters. To picture the black hole's role without getting lost in equations, imagine a city built around an ancient, heavy monument. People move around it. Roads curve around it. Districts form around it. You do not have to touch the monument for it to determine the shape of your life. The galactic center is also a region of intense activity. More stars packed together. More gravitational interactions. More energy. More radiation. If you moved Earth closer to that environment, the night sky would not look like a gentle scattering of lights. It would look like a crowd. A brilliant, pressing crowd. And with that crowd comes chaos. So here is one of the simplest, clearest examples for the audience to hold. Our location matters. We live in what you might call a relatively quiet neighborhood of a large city, not the downtown core. Not the violent outskirts of constant collisions. A calmer ring where things happen, but not too often and not too close. And yet, even here, the Milky Way carries reminders that it is not a sanctuary built for us. It is simply a place where we have managed, for a time, to fit. Neil deGrasse Tyson has said, "The universe is under no obligation to make sense to you." That sentence is a cold splash of water, but it is also a kind of liberation, because it tells us we should not expect comfort from cosmic geography. We should expect patterns. We should expect trade-offs. We should expect that what feels safe might only be a temporary alignment of factors. This is where the measuring stick becomes powerful. If our own galaxy contains supernovae, cosmic rays, magnetic storms, and a supermassive black hole at its core, then harshness is not an exception. It is part of the baseline. So when we look at nearby galaxies and ask whether they are harsher, we are really asking a subtler question. Are they harsher than our particular corner of the Milky Way? Or harsher than the Milky Way as a whole? Because those are not the same thing. A person living beside a river might call the world wet. A person living in a desert might call the world dry. Both live on the same planet. Their conclusions feel universal only because their vantage point is local. Our vantage point is local too. We look out from a sheltered niche and mistake our shelter for the rule. But the galaxy is not one climate. It is many climates stitched together by rotation and time. There are regions where star formation is raging, where massive stars live short, furious lives and die young. There are regions where dust and gas choke the view, where new suns ignite inside cocoons, unseen until they push their way out. There are regions where old stars dominate, where the light is softer, but the environment is not necessarily kinder. Because age brings its own hazards. Aging stars swell, shed layers, and change the fate of nearby worlds slowly, like a tide that never stops rising. So perhaps the most haunting thought is this. We call the Milky Way peaceful because we have been allowed to develop the luxury of forgetting the hazards. A creature that lives under constant threat does not write symphonies about the stars. It writes escape routes. It writes fear into its biology. The fact that we can contemplate the cosmos at all may be evidence that our local conditions have been unusually forgiving, not universally safe, but forgiving. And forgiveness in the universe is never a promise. It is always a window. Now let me connect this back to the promise of the episode, because this is where the story turns. We are not building fear for its own sake. We are building a yardstick, a grounded, honest baseline. If our own galactic home contains hidden violence beneath its quiet face, then we should approach nearby galaxies with humility, not assuming they are nightmares, not assuming they are paradise, but assuming they are real places with real physics, where beauty and danger can share the same light. Einstein once said, "The most beautiful thing we can experience is the mysterious." I have a destru, and maybe that is the core of why this matters. When we ask whether nearby galaxies are harsh, we are also asking what kind of universe we live in. A universe that tolerates islands of calm. A universe that allows complexity to persist. A universe that, for reasons we can describe but never fully domesticate, sometimes gives life enough time to become conscious. So we begin here, in our own house, not to flatter it but to see it clearly. We begin here because the Milky Way is the only galaxy we can feel from the inside. It is the only one whose dangers we can measure not just in telescopes, but in stories, and in scars, and in the fragile fact that we are still here to ask questions. And as we step from this baseline into the wider neighborhood, keep one thought close. The galaxies near us are not other in the way myths make them. They are variations on the same theme. Spirals and dwarfs, starbursts and quiet elders, each carrying their own mix of calm and catastrophe. So now, with our measuring stick in hand, we are ready to meet the neighbors. Because in the next movement of this journey, we will leave the comforting illusion of the familiar and step into the first chapter of the wider street. The neighbors in the dark. What if the most beautiful thing in our night sky is also one of the universe's most patient predators? What if nearby does not mean friendly? What if Andromeda is not a sister waiting to greet us, but a queen carrying the quiet trophies of ancient meals? From Earth, the Andromeda galaxy looks like a soft smear of light, a gentle breath on the black glass of the sky. It is easy to romanticize that glow, to imagine it as a peaceful city of stars, lit from within, calm and eternal. But the deeper we look, the more Andromeda begins to feel less like a postcard and more like a biography written in gravity. A biography with chapters of collision, assimilation, and slow, irresistible conquest. Astronomers have learned a hard truth about large galaxies. They do not simply sit still and shine. They grow. They feed. They accumulate mass the way oceans accumulate rivers, one stream at a time, one swallowed island at a time. In that sense, Andromeda's beauty is not separate from its violence. It is shaped by it. Carl Sagan once reminded us, "We are made of star stuff." Bringsix. Andromeda seems to take that sentence and add a darker footnote. Star stuff does not only sparkle, star stuff can be torn loose. Star stuff can be stolen. Star stuff can be folded into a new empire of light without asking permission from the smaller worlds it once belonged to. When researchers map the outskirts of Andromeda, they find faint structures that do not fit the neat symmetry of a pristine spiral. They find stretched ribbons of stars. They find shells and arcs, like ripples left behind after a stone is thrown into a still pond. These features are not decorations. They are evidence. They are the lingering fingerprints of gravitational encounters. They are what happens when a larger galaxy pulls a smaller one apart, not in a single dramatic crunch, but in a long tidal unspooling. Imagine a small galaxy approaching Andromeda the way a moth approaches a lantern. At first, nothing seems to happen. The moth is intact. The lantern glows. But as the moth gets closer, the air itself becomes dangerous. Winds form, heat rises. The moth begins to lose itself, thread by thread, wing scale by wing scale. In the same way, as a dwarf galaxy drifts near Andromeda, gravity begins to stretch it. The side closer to Andromeda feels a stronger pull than the far side. That difference in pull becomes a kind of cosmic stress. Stars start to leak away, not because the dwarf chooses to give them up, but because the math of gravity demands it. This is what galactic cannibalism means in the most literal sense we can allow ourselves. It is not teeth and blood. It is tidal forces and time. It is a slow unmaking. It is a quiet redistribution of identity. And the eerie thing is that the evidence can remain visible for a long time, like pale scars on ancient stone. You can think of those stellar streams around Andromeda as abandoned highways. Not roads built on purpose, but routes traced by broken travelers. Each stream is a memory of a smaller galaxy that once had its own center, its own rhythm, its own internal peace. Now those stars orbit Andromeda instead, as if they have been adopted by a new parent that does not know how to be gentle. Edwin Hubble once said, "Equipped with his five senses, man explores the universe around him and calls the adventure science." Tenshud, with the stature action, Andromeda is a perfect example of that adventure turning into a confrontation. Because when we explore Andromeda, we are not only admiring a distant spiral, we are reading the fossil record of violence on a scale the human mind was never designed to feel. To make this more vivid, picture a calm lake at dawn, then picture a massive ship passing through it. Not quickly, but steadily. The surface does not explode, it simply reorganizes. Waves form behind the ship. The shoreline changes. Floating leaves collect in new patterns. In a galaxy, a merger can be like that ship. The disk may warp. New waves of star formation may ignite. Old stellar orbits may be scrambled. And when the event is over, the galaxy looks beautiful again, but it is a beauty built from rearranged lives. It is tempting to think the real danger in a galaxy is the obvious kind. Supernovae, black holes, radiation flares. But the most transformative power is often the quietest one. Gravity. Gravity does not shout. Gravity persuades. Gravity is the soft voice that never stops talking, and if it speaks for long enough, it can convince entire galaxies to fall apart. This is why Andromeda's outskirts matter so much. The bright central disk is like a well-lit stage. The halo is the backstage where the old props are stored. And in that dim region, astronomers find the leftovers of past meals, loose stars, clumps that do not match the main disk's motion, faint patterns that suggest multiple mergers, not one. Stephen Hawking offered a line that feels almost like advice for standing beneath Andromeda. Remember to look up at the stars and not down at your feet. Because the way did it. Because when you look up at Andromeda, you are not just seeing a galaxy. You are seeing a lesson in scale. You are seeing what time does when it has billions of years to work with. You are seeing that the universe is not built like a museum, where everything is preserved. It is built like a river system, where everything is carried, reshaped, and eventually absorbed into something larger. And here, the idea of Andromeda as a twin becomes even more unsettling. Because if Andromeda grows this way, then the Milky Way likely does too. If Andromeda has streams of stolen stars, then our galaxy may carry its own faint ribbons too. The difference is not morality. The difference is perspective. We are inside one system, looking outward at the other, as if the neighbor is the one with the troubling history. But perhaps this is simply what large galaxies do, the way large storms gather smaller winds. There is a strange peace in accepting this. Not a cheerful peace, but a sober one, a meditative honesty, because it reframes harshness. It suggests that harshness is not an exception in the cosmos. It is the method. Creation and destruction are braided together so tightly that calling one good and the other bad feels almost childish. Still, our hearts resist. We want the universe to be hospitable. We want the sky to be a sanctuary. We want to believe that the luminous things are benevolent by nature. Andromeda challenges that longing. It whispers that beauty can be the face of power, and power does not always protect what is small. To ground this in an image you can carry, imagine a vast old tree in a forest. Its crown is magnificent. Its trunk is thick with age. Birds nest in its branches. From a distance, it looks like wisdom made visible. But beneath the canopy, smaller plants struggle for sunlight. The tree's roots drink deeply. Its shade is merciless. It does not hate the seedlings. It simply grows. Andromeda is that tree, on a cosmic scale. Its spiral arms are the crown. Its halo is the root system. And smaller galaxies that wander too close may become nourishment, not by cruelty, but by inevitability. Now, let the thought drift a little further, because it leads somewhere that feels personal. Andromeda is not just consuming the past. It is moving through space in the same broad gravitational landscape as we are. And over immense time, our galaxies are on a slow approach. Not a sudden crash, but a gradual closing of distance, like two continents drifting toward a future collision. When that far era arrives, the night sky from any surviving worlds will become unimaginable. Andromeda will grow from a faint smear to a dominating presence. Stars will be rearranged. The familiar constellations will be erased. The idea of a stable sky will become a myth told by ancestors who once lived in quieter centuries. Isaac Newton wrote, "Gravity explains the motions of the planets, but it cannot explain who sets the planets in motion." So, in the modern sense, we might extend his wonder to galaxies. Gravity explains how Andromeda eats. It explains how streams form. It explains how mergers unfold. But it does not answer the deeper question that lingers in the mind after the equations are satisfied. What does it mean that the universe grows by taking? What does it mean that the architecture of the cosmos is built from absorbed histories? What does it mean that the stars we admire may have been orphaned long ago? And yet, there is another layer. Because within that harshness, there can also be possibility. Mergers can trigger new star formation. They can mix elements. They can reshape galaxies into forms that later become calmer. In a paradoxical way, violence can be creative. Andromeda's grandeur may partly exist because it has eaten. Its richness in stars may be the inheritance of many smaller homes. Its halo may be a library of stolen chapters, each one contributing to the final, luminous book. This is why I call it the beauty of a predator, not to accuse it, but to describe it honestly. A predator in nature is not evil. It is a force that keeps the ecosystem moving. It is a reminder that life and death are not opposite kingdoms, but adjacent rooms. Andromeda, in the cosmic ecosystem, plays that role. It gathers. It consolidates. It becomes the archive of what once was separate. So when you look at Andromeda next time, try a different kind of gaze. Not a tourist gaze, a listening gaze. Let the light that left it millions of years ago arrive in your eyes like a letter written in an ancient language. Let that letter say, softly, that the universe is older and more complicated than comfort. Let it suggest that even the nearest neighbors carry histories that would make our myths feel small. And then ask yourself the question that sits beneath all of this, the question that refuses to leave. If the most familiar-looking galaxy beyond our own is built from acts of cosmic consumption, what does that imply about the wider universe? How many galaxies are assembled this way? How many starry cities are really mosaics of conquered towns? How many halos are cemeteries of former identities? Because perhaps the real shock is not that Andromeda is harsh. Perhaps the shock is that harshness can look so beautiful from far away. And perhaps the deeper invitation is this: to stop expecting the universe to behave like a story written for our comfort, to see it instead as a vast, living process, indifferent but not meaningless, where even destruction can become a kind of transformation. And as we move forward, we will step closer to the shadows around Andromeda, to those faint stellar streams that act like its whispered confessions. We will ask what they reveal about the smaller galaxies that vanished. We will ask how astronomers read these ghostly structures as evidence. And we will return to the unsettling idea that nearby is not a promise of safety, but simply the next page in a very old book. What if the most dangerous place in a galaxy is not the blazing core, but the quiet edge where small worlds try to survive in the shadow of a giant? Around the Milky Way, dozens of dwarf satellite galaxies drift like fragile boats on a deep gravitational sea. From far away, they look peaceful, almost cute, like embers floating near a campfire. But up close, near, can mean being slowly pulled apart, star by star, memory by memory, until you become a stream of light with no home. To understand these satellites, we have to unlearn a comforting instinct. We assume closeness equals safety. We imagine neighbors sharing warmth, yet the universe does not do friendship the way we do. It does gravity. It does tides. It does long, patient pressure. As Neil deGrasse Tyson put it, the universe is under no obligation to make sense to you. Thanks for watching. And in the case of satellite galaxies, it often feels as if the universe is under no obligation to be gentle either. These dwarfs are small, yes, but their stories are enormous because they are living laboratories for a brutal truth. In cosmic ecosystems, the small are shaped by the large, not by intention, but by inevitability. Imagine holding a grape between your fingers and slowly twisting. The grape resists at first, then the skin tightens, then it splits. That is tidal stretching in its simplest emotional form. A dwarf galaxy is a loose swarm of stars and gas held together by its own gravity, often with a cloak of dark matter that gives it extra grip. But when it orbits a giant galaxy like the Milky Way, it enters a region where gravity is no longer uniform. The near side feels a stronger pull than the far side. Over time, this differential tug acts like invisible hands, pulling it longer and thinner. The dwarf becomes distorted. Then it begins to shed stars. Those stars do not vanish. They become tidal streams, ghostly ribbons wrapping around the Milky Way like pale scars. This is why the outskirts of our galaxy are not truly empty. They are full of remnants, full of quiet evidence that small galaxies have come too close and paid a price. Some are still alive, still orbiting, still trying to hold themselves together. Others are already halfway gone, stretched into luminous trails that future astronomers will read like handwriting on the dark. Now, to make this feel real, picture a familiar example. Look at the large Magellanic Cloud and the small Magellanic Cloud. From Earth's southern skies, they appear as soft, detached smudges, like breath on glass. It is tempting to romanticize them as companions, but they are also participants in a dynamic three-body relationship with the Milky Way, and gravity is the third partner that never sleeps. Between the Magellanic Clouds, there is a bridge of material, and trailing behind them is a long stream of gas arcing across the sky, a sign that interactions, stripping, and tugging have been happening for a very long time. Even when the view is beautiful, the process can be harsh. Harshness in space is not always loud. Sometimes it is deprivation. A dwarf galaxy lives and dies by its gas. Gas is not just stuff. End quote. Every one of the free sum that. Gas is possibility. Gas is the raw material for new stars, new planets, and any chemistry that might someday become biology. But when a dwarf galaxy plunges through the extended halo of hot gas around the Milky Way, it can experience ram pressure stripping. Think of a cyclist riding into a strong wind. The wind does not care who you are. It simply pushes. Now replace wind with a thin, hot, ionized medium, and replace cyclist with a fragile galaxy. Over time, the dwarf can lose the very fuel it needs to continue forming stars. It becomes quenched. It fades. It turns from a living city of star birth into a quiet museum of old light. This is one of the most haunting ideas in modern astronomy. A galaxy can be starved, not exploded, not destroyed in a single dramatic moment, starved slowly, as if the universe can end a civilization not with a bang, but with the gentle removal of tomorrow. And then there is the Sagittarius dwarf galaxy, one of the clearest examples of life on the edge becoming unmade. It is currently being disrupted by the Milky Way. It is not a rumor or a metaphor. Its stars are being pulled into streams that wrap around our galaxy. If you want an image for the mind, picture a small candle drifting too close to a massive whirlpool. The flame still burns, but the wax is already unraveling. The candle does not realize it is becoming part of the whirlpool's story. Yet it is. When we say satellite, we often imagine a stable orbit, something tidy and predictable, like a moon circling a planet. But galaxies are not solid objects. They are fluid collectives. They breathe through gas flows. They change shape through tides. They carry the scars of every close pass. So, a satellite galaxy is less like a moon and more like a migrating flock of birds, trying to remain a flock while flying through a storm. This is where the cosmic scale becomes almost spiritual, because the time scales are so long that they start to feel like fate. A dwarf galaxy might orbit the Milky Way for billions of years. It might survive multiple close encounters. It might lose a little gas each time, shed a few stars each time, like a traveler leaving threads of clothing on thorns along the road. And one day, after enough orbits, it may no longer be a galaxy in the way it once was. It becomes an accreted component of the Milky Way's halo. Its identity dissolves into a larger identity. Not because anyone chose it, but because gravity kept remembering the path and pulling it back. Carl Sagan once wrote, "Somewhere, something incredible is waiting to be known." Thanks for watching. One of those incredible things is that the Milky Way is not a single, isolated structure. It is an ongoing merger, a long banquet of smaller galaxies absorbed over time. The halo of our galaxy contains ancient stars that likely came from dwarfs that no longer exist as separate objects. In other words, when we look at satellite galaxies today, we may be looking at living versions of our own past. We may be watching, in real time, the process that helped build the Milky Way itself. This connection matters because it changes the emotional tone of the topic. Satellite galaxies are not just victims. They are contributors. They are the donors of stars, gas, and dark matter that have shaped the larger galaxy's growth. They are like small tributaries feeding a great river. The river grows powerful, wide, and ancient, and later we forget the tributaries existed. But the river is made of them. The Milky Way, in a very real sense, is a memory palace constructed from smaller memories. Now consider how harsh can also mean unpredictable. Dwarf galaxies are especially sensitive to their environment. A slight change in orbit, a close pass near another satellite, a shockwave from star formation, a burst of radiation. Any of these can push them into a new phase of evolution. They can be irregular, chaotic, and lopsided, not because they are poorly made, but because they are constantly being stirred. If a large galaxy is an ocean, then dwarf satellites are rafts. They can cross calm waters, but they live at the mercy of tides. And yet, there is a subtle twist here that makes the story even more compelling. Because some dwarf galaxies appear to be dominated by dark matter. This makes them strange fortresses, tiny in light, heavy in gravity, harder to tear apart than their visible stars would suggest. It is as if the universe built them with invisible bones. So when we watch a dwarf galaxy resisting tidal forces, we are not just watching a small galaxy struggle. We are also watching dark matter reveal its influence. We are watching the unseen show itself through the behavior of the seen. This is why the satellites matter to scientists in a very practical way. They are test beds. They help us infer the structure of the Milky Way's dark matter halo. They help us understand how galaxies form stars in extreme conditions. They help us explore why some systems retain gas while others lose it. They even feed into larger puzzles, like the distribution and number of satellites predicted by cosmological models. In a universe where so much is invisible, satellite galaxies become clues written in faint ink. But let's return to the human feeling of it, because that is where your audience lives. Picture standing on a shoreline at night. The ocean is calm, but you can feel the pull. The moon does not touch the water, yet it raises tides. Now scale that idea up beyond comprehension. A satellite galaxy does not collide with the Milky Way most of the time. It does not need to. It only needs to be close enough for gravity to keep pulling, shaping, distorting, and slowly rewriting its future. That is the kind of harshness that feels almost intimate, a force that does not strike once, but stays. So, are nearby satellite galaxies truly harsh environments? If by harsh you mean violent explosions every moment, not necessarily. If by harsh you mean living under constant pressure, constant stripping, constant reshaping, then yes, many of them exist in a state of ongoing vulnerability. They live on the rim of a giant's influence. They survive, but often at a cost. And the closer they come, the more that cost increases. There is also a final, unsettling reflection. We often imagine that life, if it exists elsewhere, would prefer stability. A steady star, a quiet galactic neighborhood, a long span of calm conditions. But if any life ever arose inside a satellite dwarf, it would have to endure a sky that changes on cosmic timescales. Star formation might flare, then fade. Gas might be removed. Radiation environments might shift. And over billions of years, the very galaxy that hosts that life might be stretched into streams and absorbed. What does home mean in a universe where even galaxies can be temporary? As Richard Feynman once said, nature uses only the longest threads to weave her patterns, so each small piece of her fabric reveals the organization of the entire tapestry. When dies, satellite galaxies are small pieces, but they reveal the tapestry. They reveal how large galaxies grow. They reveal how gravity sculpts structure. They reveal how the universe can be both creative and indifferent at the same time. And that brings us smoothly to the next step in the story. Because once you understand life on the rim, you begin to wonder about the regions where the rim becomes something else entirely. Where galaxies are not just orbiting a single giant, but living inside crowded groups, pulled by multiple masters. Where the idea of a neighbor becomes a swarm, and harshness becomes collective. So now, let us move forward, deeper into the darkness, and ask what happens when near is not a relationship between two galaxies, but an entire neighborhood pressing in from all sides. What do you think? Are satellite galaxies tragic survivors, or are they simply doing what the universe does best, transforming, merging, and becoming something larger? And if our own Milky Way was built from many small galaxies long ago, could it be that we are not merely observing them? Could it be that we are, in a strange way, watching echoes of our own origins? What if the most dangerous thing a galaxy can do is not explode? What if the true threat is that it can simply stop breathing? We grow up imagining the universe as a theater of fireworks. Supernovae cracking open like celestial drums. Black holes swallowing light with theatrical hunger. Colliding galaxies painting the sky with ribbons of blue newborn stars. But harshness is not always loud. Sometimes harshness is the long quiet after the music ends. And that is the strange truth hidden inside your idea. A galaxy can be violent and still feel alive. A galaxy can be peaceful and already be dying. Not with a scream, but with a slow dimming that no one witnesses. Not with a flash, but with an absence. Not with a catastrophe, but with a gradual forgetting. So, let me ask you a question that sounds simple, but opens a door that is hard to close. If a galaxy runs out of the raw material to make new stars, if it becomes quenched, if it turns from a living furnace into a quiet museum of old light, Is that not its own kind of cruelty? Because star formation is not just decoration, it is the heartbeat. It is the ongoing conversation between gravity and gas. It is the reason spiral arms glow like wet paint under starlight. When that stops, a galaxy becomes an archive. Beautiful, yes, but cold in a way that feels final. Astronomers sometimes describe this like a body losing its oxygen. Not dramatic at first, not obvious, just a little less color in the cheeks, a little less energy in the limbs, and then one day you realize the room has been quiet for a long time. There is a line I return to whenever I try to explain this kind of cosmic silence. For a long time, we have suspected that running out of gas is one of the main reasons that some galaxies cease to form stars, but now we have the evidence. That is Georgios Magdis, speaking for a team that studied distant galaxies that had already gone quiet. And notice the shape of the sentence. Not triumph, not celebration. Evidence, yes, but also a kind of grief, because the evidence points to something irreversible. To make this real, imagine a city, not a city of people, but a city of light. The street lamps are stars. The construction crews are star-forming clouds. The fuel trucks are cold hydrogen gas drifting in from the cosmic web. As long as the fuel arrives, the city grows. New neighborhoods appear. New lights switch on. The skyline changes. But if the fuel trucks stop coming, the city does not explode. It simply ages. The oldest lamps keep shining for a while, because old stars can glow for billions of years. But the construction cranes freeze midair. The newest districts never get built. The city becomes quieter each decade, and eventually you are walking through a place that is still standing, still luminous, but no longer becoming. This is why harshness can be silent. Because life, even cosmic life, is not only about surviving, it is about continuing. Now let us move gently from metaphor to mechanism, without breaking the mood. Galaxies form stars from cold gas. That gas is the precious, fragile ingredient. It can be used up. It can be heated so it cannot collapse. It can be stripped away by an environment that is bigger and meaner. Or it can be prevented from entering in the first place. Picture a spiral galaxy as a breathing creature. It inhales gas. It exhales stars. It cycles material through generations, enriching it, thickening it, seasoning it with heavy elements. When the inhale stops, the creature does not instantly die. It just begins to run on what it has left. And that leftover can last a long time, long enough to fool an observer into thinking nothing has changed. But the direction has changed. The arrow points toward quiet. This is where the universe becomes unsettlingly familiar, because we have all seen this kind of ending. A room that used to host laughter, and then slowly does not. A town that once had factories humming, and then, year by year, does not. Nothing dramatic happens on a single day, and yet something is gone. Astronomers sometimes call these galaxies red and dead. The phrase is blunt, almost unfairly casual, but it captures an observable truth. Young, hot stars shine blue and bright. They are short-lived, like sparks. If a galaxy stops forming them, the galaxy's light shifts toward older, cooler stars, which appear redder. So the color becomes a symptom, not a decoration, but a diagnosis. And the most haunting part is this. The galaxy may look calm through a telescope. No explosions, no obvious chaos, just a smooth oval glow like a lantern seen through fog. But that calmness is not peace. It is exhaustion. How does a galaxy get there? There are several pathways, and each one feels like a different kind of silence. One pathway is simple consumption. A galaxy converts its gas into stars too quickly, like a person burning through savings during a brief season of prosperity. For a while it looks magnificent. Starburst regions blaze. The spiral arms glitter. Then the fuel drops. The galaxy cannot keep up the performance. It becomes quiet by its own success. Another pathway is starvation. A galaxy may rely on a slow, steady drizzle of fresh gas from the cosmic web. If that supply is cut off, perhaps by the gravity and heat of a larger environment, the galaxy is not attacked directly. It is merely denied. No new fuel arrives. No fresh clouds form. And gradually, the star-making engine winds down. This is harshness as withholding. Another pathway is stripping, and here the cruelty feels more physical. Many galaxies live in clusters, where hot, thin gas fills the space between galaxies like an invisible ocean. When a smaller galaxy moves through that medium, the pressure can sweep its own gas away, the way wind tears leaves from a tree in autumn. The galaxy keeps its stars, but loses its future. It becomes a skeleton that still shines. And then there is the pathway that feels like self-sabotage. A supermassive black hole at the center of a galaxy can flare into activity. When it does, it can pump energy into the surrounding gas, heating it, stirring it, or even blasting it outward. It is not that the black hole hates stars. It is that the black hole's feeding changes the weather of the entire galaxy. The gas becomes too hot to fall inward and form new suns. In a strange way, the galaxy's own heart can become the reason its arms go cold. This is the point where we can offer a vivid example that people can feel in their bones. Imagine boiling water. Cold gas is like liquid water that can pool and gather. Hot gas is like steam, spread thin, reluctant to condense. A galaxy needs the liquid state, the gathering state, the collapse into dense clouds. If the entire system is turned into steam, the recipe for new stars is still there in terms of atoms, but the conditions are wrong. The ingredients are present, but the kitchen is too hot to cook. Now, let us connect this back to your central line. Moi trung kak niet không phải lúc nào cũng ồn ào. Yes, because a galaxy can be harmed by quiet physics, by slow heating, by gentle stripping over time, by missing fuel deliveries, by a long era in which nothing dramatic happens, and that is precisely the problem. There is another sentence from the scientific reporting on this topic that lands like a verdict. Once a galaxy's star formation shuts off, it rarely turns back on. That idea should make you pause, because it implies finality. It implies that the universe contains not only birth and transformation, but also retirement, permanent aging, a door that does not swing back open. When you look at images of galaxy clusters, you often see this difference instantly, even without knowing the math. Spiral galaxies, with their blue knots of star formation, look like living things. Elliptical galaxies look like ancient stones glowing faintly at night. They are not ugly. They are serene, but it is the serenity of an ending. And here is where I like to broaden the emotional lens, because this is not only about astrophysics. It is about what we humans tend to misunderstand. We are trained to notice events. We notice impacts. We notice noise. But the universe is equally shaped by what does not happen, by the star that is never born, by the cloud that never collapses, by the spiral arm that never lights up again. To make that clearer, imagine standing on Earth under a sky that has been stable for your entire lifetime. The constellations change so slowly that they feel eternal. Now imagine living on a planet inside a galaxy going quenched. In the early era, the night sky might be crowded with bright blue star-forming regions, shimmering like cosmic cities under construction. Then, over millions of years, the new lights stop appearing. The sky still has stars, still has beauty, but the feeling changes. It becomes a sky of inheritance rather than a sky of promise. That shift is difficult for us to grasp because our emotional time is short. But in the language of galaxies, it is a decisive transformation. A galaxy becomes a place where the past dominates the present, where the future is mostly reruns. Now we can weave in a quote that reminds people why this matters to them, without drifting into sermon. Carl Sagan once said, "The cosmos is within us. We are made of star stuff." We are a way for the universe to know itself. That line is famous for a reason, because it makes the universe intimate. And once the universe is intimate, the death of star formation in a galaxy no longer feels like a distant statistic. It feels like a story about origins, about the source of the atoms that become worlds, and oceans, and eyes. If star formation is the universe's way of making new chemical possibilities, then a quenched galaxy is a universe that has stopped improvising. It is still playing, but only the old notes. Still glowing, but only with inherited fire. So the harshness you describe is not merely absence. It is the end of renewal. It is the end of surprise. It is the end of the galaxy as a workshop. And now, if we want to make this persuasive, we should acknowledge the temptation many viewers feel. They want the dramatic version. They want the collision. They want the blast. They want the villain. But the universe is rarely that theatrical. It is more honest, more indifferent, more patient. It does not always kill with a sword. Sometimes it kills with time. That is why your idea is powerful, because it teaches the audience to respect quiet processes, not by labeling it as a lesson, but by making them feel it, by guiding them into a silence that has structure, by showing them that a galaxy can die in a way that resembles a candle, not a bomb. And now we arrive at the natural bridge, the thread that pulls us forward without snapping the spell. If galaxies can become dead without any obvious violence, if the universe can erase futures not by destruction, but by deprivation, then we must ask the next question, the one that deepens the unease. What happens when galaxies do not merely go quiet on their own? What happens when they pass near one another, and gravity begins to reshape them like a slow hand-bending soft metal? Because sometimes the silence is not the end of the story. Sometimes the silence is what comes before the encounter, and in the next part, we will step into that moment. The moment when galaxies go by each other, and the universe proves that even gentle forces can rewrite destinies. Have you ever wondered what really happens when two entire galaxies pass through each other? Not as a Hollywood crash of burning stars, but as a slow, silent rewriting of destiny that unfolds over millions of years. We are used to thinking in collisions. Car meets car, stone meets stone, but galaxies are not stones. They are more like ghostly cities made of light, mostly empty space, stitched together by gravity and time. And that is the first surprise. When galaxies meet, they usually do not smash star into star. They pass through, like two vast schools of fireflies drifting through the same summer field. It feels gentle when you say it that way. But the gentleness is only on the surface, because even if stars rarely collide, gravity always does. Gravity reaches out first. Gravity touches from far away. Gravity does not need contact to change everything. John Archibald Wheeler captured this with a line that has become almost a prayer in modern physics. Space-time tells matter how to move. Matter tells space-time how to curve. And in that curving, in that invisible persuasion, the shape of whole galaxies can be pulled like soft taffy. So imagine two spiral galaxies approaching. From a distance, they look calm, like two luminous pinwheels drifting in a black ocean. But as they draw near, their outer arms begin to feel a tug that is not quite their own. Orbits that were once predictable become stretched. Stars that have circled peacefully for billions of years find their paths subtly altered. Not violently at first, just slightly, like a compass needle that begins to drift without warning. Then, the long drama begins to accelerate. The galaxies do not collide like billiard balls. They interpenetrate. Their stars pass by one another with miles and miles and miles of emptiness between them. If you could stand on a planet inside one of those galaxies, you might not see a single star crash in your sky. You might even think nothing is happening, and yet everything would be happening, because the true collision is between gravitational fields. The true impact is on the orbits of gas clouds. And gas, unlike stars, is social. Gas cannot ignore a crowd. When galaxies pass through each other, their gas clouds can compress and slam together. They can shock. They can fold. They can pile up like weather fronts meeting over a warm sea. And out of that compression, new stars ignite in vast numbers. This is why galaxy encounters can trigger starbursts. Not one star, not 10 stars, but entire waves of star formation, as if the galaxies themselves are forced to remember how to burn brighter. Carl Sagan once said, "We are made of star stuff." It is a famous line because it is both poetic and precise. But in a galaxy encounter, that star stuff is being manufactured at scale. It is being minted in cosmic furnaces that flare into existence because gravity pressed the raw ingredients together. In other words, an encounter that looks peaceful from far away can become a factory of suns. Now, let us make it easier to picture. Think of two slow-moving storms meeting over an ocean. The air itself does not crash like a wall. It mixes. It spirals. It thickens in places. And suddenly, lightning begins. Not because the storms hit like rocks, but because their invisible structures interacted. A galaxy encounter is like that. Two great weather systems of gravity, and the lightning is newborn stars. And here is where the word harsh begins to earn its weight, because for any planet caught inside such a region, the sky changes. Not just in beauty, in danger. When star formation surges, massive stars appear. Massive stars live fast. They burn hot. They die young. And their deaths are not quiet. They end as supernovae, flooding surrounding space with radiation and heavy elements. So, a starburst era can mean an era of frequent nearby supernovae. For life, that can be catastrophic. For chemistry, it can be transformative. For the night sky, it can be both stunning and terrifying. Picture a world that once had a stable, familiar pattern of constellations. Then, over a few million years, the constellations distort. New bright points appear where none existed. Nebulae bloom. Whole regions of the sky grow luminous with star-forming clouds. The galaxy's graceful arms may stretch into long tidal tails, streams of stars pulled outward like silk. And if that planet has observers, they might write myths about the sky being torn open. They might feel, deep in their bones, that the cosmos has entered a different mood. This is not fantasy. We see it in the universe. We see interacting galaxies with long tidal tails. We see systems where the encounter has drawn out ribbons of stars across space. We see galaxies whose central regions blaze with intense star formation. Even if we are speaking gently, the physics is unambiguous. Close passes rearrange structure. Gravity edits the architecture of galaxies. And there is another twist, quieter but even more profound. Galaxy encounters can feed the monsters at their centers. Many large galaxies harbor supermassive black holes. Most of the time, these black holes are quiet. They sit in darkness, immense but restrained. But an encounter can funnel gas toward the center. Gravity can drive matter inward. And when a supermassive black hole begins feeding, it can ignite as an active galactic nucleus. That means jets. That means powerful radiation. That means a lighthouse beam of energy that can outshine the combined starlight of the galaxy itself. If you lived on a planet near that center, the night might not be night anymore. A hard brilliance could dominate the sky. Not warm like a sun, sharper, more alien. A radiance that feels like a warning. In that sense, the harshness is not only in collisions, it is in awakenings. A galaxy encounter can wake a sleeping giant. So when we say stars rarely collide, we must not mistake that for safety. A forest can be devastated without trees hitting each other. A coastline can be reshaped without rocks colliding. A human life can change without a single visible impact. A galaxy is similar. It can be rewritten without direct star-to-star crashes. Now let us follow the thread more slowly and connect it to something almost meditative, because the universe teaches us a lesson that is easy to miss. The The most powerful forces are often the least theatrical. Gravity has no sound. It has no color. It does not announce itself. And yet, it is the author of the largest transformations we know. Neil deGrasse Tyson has a line people repeat because it stings with truth. The universe is under no obligation to make sense to you. And maybe we can add something softer to that. The universe is under no obligation to be gentle just because it looks beautiful. So what does a galaxy encounter feel like in the language of time? For us, it is unimaginable. Millions of years is longer than the entire history of human civilization. But for a galaxy, a few million years is like a breath. A slow inhale, a slow exhale. In that breath, star formation surges. Orbits shift. Central black holes may flare, and after the encounter, the galaxies may separate again, scarred but still distinct. Or they may merge, becoming a new galaxy altogether. A new shape, a new identity, a new memory written in stars. This is why some astronomers describe galaxy mergers as a kind of evolution, not biological, but structural. Small systems combine into larger ones. Disks can be disrupted. Elliptical galaxies can form from repeated mergers. The universe builds complexity through encounters, and it does so without hurry. It is patient. It is relentless. Let us offer one more image to make it real. Imagine two dancers moving toward each other on a dark stage. They do not collide. They weave. Their motions influence each other, and the choreography changes mid-performance. Now replace dancers with galaxies. Replace choreography with gravity. And replace the audience with any life that might be watching from within. The dance is elegant, but it is not harmless. So when we return to the line you began with, the truth becomes clearer. Galaxies passing through each other are not gentle events. They are gentle in appearance. They are harsh in consequence. They are calm at the level of stars. They are violent at the level of gas. They are quiet in the moment. They are transformative across time. And here is the final turn of the thought, the one that makes the heart tighten a little. Our own galaxy is not isolated forever. We are part of a local neighborhood of galaxies. We have nearby companions. We have future encounters written into the mathematics of motion. To understand what happens when galaxies go through each other is not to watch a distant drama. It is to glimpse a chapter that the cosmos may one day open closer to home. Somewhere, Sagan also reminded us that somewhere, something incredible is waiting to be known. In this case, the incredible thing is not only knowledge, it is perspective. Because once you see how galaxies can change without obvious collisions, you start noticing that the universe is full of quiet forces shaping everything. You start to feel that the sky is not a static ceiling, but a living river of time. And you begin to ask the next question naturally, almost inevitably. If gravity can rewrite galaxies so profoundly, what does it do to the smaller worlds hidden inside them? What does it mean for planets, for atmospheres, for life trying to persist beneath a changing sky? And that is where we go next. Because now that we have stepped into the slow dance of galaxies passing through each other, we are ready to look up from the scale of stars and ask what it feels like from the ground of a single world, watching its heavens transform. What if the greatest danger in the nearby universe is not distance, but intimacy? Not the unknown, far beyond the cosmic horizon, but the familiar light just next door. When we look at a nearby galaxy through a telescope, it feels like a lantern in the wilderness. A soft swirl of stars. A calm, luminous city of suns. Yet that elegance can be a mask, because some galaxies do not merely shine. Some galaxies shout. Some galaxies exhale violence in beams so concentrated that, if you were close enough, an entire world could lose its sky. Carl Sagan once reminded us that we are made of star stuff. In Tries, it is a beautiful line, but it carries a hidden edge. Because the same universe that made our blood from ancient supernovae also manufactures radiation, shock waves, and cosmic engines that do not care what breathes. In other words, the universe is not hostile. It is simply indifferent, and indifference at the wrong distance can feel like cruelty. So, let us begin with the first image you should hold in your mind. A planet, not unlike Earth in mass and size. A thin skin of air, oceans, clouds, a gentle night. Now place that planet not in the quiet outskirts of a spiral galaxy like our neighborhood of the Milky Way. Place it closer to the core of a galaxy with an active nucleus, a region where the center is not just a crowded downtown of stars, but a furnace with a mouth, a supermassive black hole feeding on gas, dust, and sometimes entire stars. As it feeds, it does not swallow politely. It converts infall into light and particle storms. It turns gravity into a lighthouse of lethal brilliance. And then, from the poles, it can launch jets. Narrow, relativistic, needle straight across thousands of light years. A cosmic searchlight sweeping darkness with energy. This is not science fiction. It is one of the most dramatic behaviors we observe in the real universe. Astronomer Edwin Hubble famously expanded our sense of scale when he showed that the nebulae were galaxies beyond our own. And in doing so, he helped open the door to an unsettling truth. The universe is not only bigger than we thought, it is wilder than we assumed. Here is a simple way to feel it. Think of the atmosphere of a planet as a fragile perfume held in a shallow bowl. It is easy to spill. On Earth, our magnetic field and thick atmosphere help cushion us from much of the sun's anger. Even then, solar storms can disrupt satellites and power grids. Now imagine a star system living under a harsher lamp. Not a calm Sunday, but a galaxy core that flickers with X-rays, gamma rays, and charged particles. In that environment, the bowl does not merely tremble. It gets slapped. Over and over. Ionizing radiation can break molecules apart. It can strip away ozone. It can erode upper atmospheres like wind peeling paint. And if a jet or powerful burst points even roughly your way, the loss could be sudden. Not a slow climate change across millennia, but an atmospheric collapse on timescales that, in cosmic terms, are the blink of an eye. Stephen Hawking put it bluntly in his own way when he said, "The universe doesn't allow perfection. When for it now, it is a line that fits here. Because the skies of many worlds, if they exist, are not designed for comfort. They are negotiated. They are defended. They are temporary treaties between chemistry and chaos." And yet, here is where the story turns from fear into something more interesting. Because danger does not automatically mean emptiness. Harshness does not automatically mean lifelessness. It only means life would have to become clever. Life would have to become patient. Life would have to become strange. Picture an ocean world, not a green continent under blue skies. An ocean that never sees daylight. Ice on top, black water below. Hydrothermal vents at the bottom, glowing faintly like undersea candles. On Earth, we already know ecosystems can thrive around vents, using chemistry rather than sunlight. Now, stretch that idea into a galaxy where the surface is routinely blasted by radiation. In such a place, the safest sky might be a ceiling of ice. The safest day might be darkness. The safest garden might be buried beneath kilometers of water and rock. Life, if it exists, might not write poems to the stars. It might not evolve eyes. It might not care about constellations. It might live as a slow intelligence of currents, heat, and minerals, protected from the heavens above. This is why the phrase harsh environment is often a confession more than a conclusion. It is harsh for us. It is harsh for creatures like us, built on thin air, sunlight, and mild weather. But the universe is under no obligation to produce only our kind of fragile miracle. As the biologist J.B.S. Haldane is often credited with observing, The universe may be queerer than we can suppose. 18, said Alotian. And if that is true, then what we label dangerous could be, for something else, simply home. So when we ask, Kak niet vai, we are really asking a deeper question. Are we searching for life? Or are we searching for our own reflection? Are we looking for biology? Or are we looking for a second Earth because the first Earth is the only story we know how to read? There is a quiet humility in admitting that, because it reframes the whole hunt. It suggests that the universe might be full of living systems that do not sit comfortably inside our definitions. They may not bloom under gentle suns. They may persist in places where our instincts say, no, not there, impossible. And yet, the history of science is the history of impossible becoming real. Now let us glide into the final idea, because once you accept that harshness depends on the observer, another truth becomes unavoidable. Near does not mean safe. Near only means visible. We say nearby galaxies, as if they are the quiet suburbs of the cosmos. But proximity in astronomy often comes with a past written by gravity, a past filled with mergers, tidal stripping, bursts of star formation, and long epochs of rearrangement. Galaxies grow by collision, not like billiard balls smashing, more like ghosts passing through ghosts, their stars rarely hitting, but their gravitational fields grabbing and reshaping everything. Spiral arms twist, gas clouds compress, new stars ignite in frantic waves, old structures tear. A galaxy can look serene in a photograph and still be in the middle of a slow catastrophe. Here is an example you can feel without equations. Imagine two vast schools of fish in a dark ocean. They drift toward each other, each one guided by invisible currents. When they overlap, it is not a single crash. It is a confusion of motion. Some fish are pulled into tighter spirals. Some are flung outward into emptier water. Some find themselves suddenly surrounded by pressure and friction that forces a transformation. A galaxy merger is like that, but with stars and gas and time. And if you happen to live on a planet inside one of those systems, your night sky would change. New bright regions would appear. A dense band of stars might stretch across the heavens. The rate of nearby supernovae might climb as new massive stars are born and die. The very rhythm of the cosmos above your world would become more dramatic. This is why close can be misleading. We can see nearby galaxies more clearly, so we notice their scars. We notice their jets. We notice their bursts. We notice their cannibalism. But that does not mean the distant galaxies are gentler. It may only mean we cannot yet see their violence in detail. Near does not mean more dangerous. Near means our eyesight reaches them with less effort. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you. Thanks for watching." That is not an insult. It is a kind of liberation, because it reminds us that our instincts are shaped by one tiny habitable bubble, a single calm orbit, a single fortunate distance from a single star. We are judging the ocean by the warmth of one sheltered bay. And yet, there is something strangely comforting in this, because it means the universe is honest. It does not pretend. It does not promise safety. It simply unfolds. Worlds lose their skies. Worlds hide under ice. Stars flare. Black holes feed. Galaxies collide in slow-motion beauty. And somewhere in that vastness, pockets of stability appear, not as a right, but as a rare alignment, a balance, a pause, a small sanctuary between storms. So perhaps the real message of nearby galaxies is not terror. It is perspective. It is the reminder that our calm is not the default setting of reality. It is a special configuration, held together by delicate conditions that could have been otherwise. And that makes our own sky feel more precious, not less, because every breathable night is a victory over the odds. Now, as we step forward, hold on to one final thought. If galaxies can wear beauty like a veil over violence, if harshness is sometimes only a matter of who is doing the surviving, if near is merely a privilege of visibility, not a guarantee of safety, then the next question becomes inevitable. Where, exactly, does our own neighborhood sit inside the long, dangerous memory of the cosmos? And what does it mean that we are here to ask at all? And that is why, in the next part, we must begin where all these truths converge. With the neighbors in the dark, with the nearest lights that look gentle from afar, and with the hidden histories they carry in their glow, perhaps the real question is not whether nearby galaxies are harsh. Perhaps the deeper question is how quietly we have been living. We wake each day beneath a sky that rarely reminds us of its power. Our star burns steadily. Our atmosphere holds. Our nights arrive without radiation, storms tearing the air apart. And over time, that calm begins to feel normal, expected, deserved. But what if this calm is not the rule? What if it is an intermission? A pause written into a much louder cosmic story. Across the universe, galaxies collide, stars explode, and skies are stripped away without hesitation. Against that backdrop, the Milky Way may not be gentle by design. It may simply be quiet for now. If our galaxy is only a temporary exception, then our existence takes on a different meaning. Life becomes less a triumph of inevitability and more a fragile alignment of timing and place. A memory forming even as it unfolds, something allowed to happen, briefly, between vast movements that do not notice us at all. And that realization does not diminish us. It sharpens us. Because to live inside a rare silence is to carry responsibility for remembering it, and to ask, while we still can, what it means to be here at all.